Last week, the sun fired 4 massive flares at Earth. 4 in one day. Within minutes, radio signals degraded. Pilots lost communication over the poles. GPS accuracy dropped. And that was just the radiation. What could have followed was much worse. To understand why, we need to go back to 1859. Telegraph operators watched their machines catch fire. Sparks flew from the wires. Some operators got electric shocks. Auroras lit up the sky over the Caribbean. Nobody understood what was happening. The sun had attacked Earth, and last week it reminded us it could do it again. 4 massive solar flares, one single day. Not minor flickers, not background noise. 4 violent eruptions within hours. If you think that sounds dramatic, wait until you hear what almost happened in 2012. But I'll get to that in a moment. First, you need to understand what's actually firing at us. Right now, as you're watching this, the sun looks calm, golden, steady, peaceful. But beneath that surface, something violent is happening. Magnetic field lines are twisting, tangling, building pressure. And when that pressure becomes too much, they snap. In seconds, the sun releases more energy than every nuclear weapon on Earth combined. That energy races toward us at the speed of light. 8 minutes. That's all it takes to reach you. And here's what happens when it does. Radio signals start failing. Pilots flying over the poles lose communication. Ships lose GPS accuracy. Air traffic controllers scramble to reroute flights. All from radiation you can't see, can't hear, can't feel. But that's just the warning shot. The real threat comes next. Picture this: 1 billion tons of charged plasma, ripped from the sun's surface, hurtling through space at millions of kilometers per hour. This is a coronal mass ejection, a CME. And if one of these is aimed at Earth, you have maybe 18 hours before impact. 18 hours, that's your warning. When it hits, Earth's magnetic field compresses like someone squeezing a balloon. Energy pours into the atmosphere. And here's the part that should make you uncomfortable. That energy doesn't just stay in the sky. It creates electrical currents in anything long and conductive on the ground. Power lines, pipelines, railway tracks. Your entire electrical grid becomes an antenna, and antennas can overload. Imagine every transformer in your city failing at 3 a.m. Now imagine it's not just your city. Imagine it's half your country. That's not science fiction. That's what almost happened 11 years ago. July 2012. A CME exploded from the sun. Massive, powerful, comparable to the 1859 event that set telegraph offices on fire. It crossed Earth's orbit, but Earth wasn't there. We had passed that exact point in space 9 days earlier. 9 days. If that eruption had happened just over 1 week sooner, you might have grown up in a very different world. Satellites destroyed, GPS systems offline, power grids collapsed across multiple continents. Estimated damage? $2 trillion, years of recovery. And that was just luck. We didn't prepare, we didn't prevent it. We just weren't there when the bullet crossed our path. Now ask yourself something. What are the odds that keeps happening? Because here's what scientists are tracking right now. The sun follows an 11-year cycle. At the start, it's quiet. Few sunspots, few eruptions. But as the cycle builds, magnetic activity intensifies. More sunspots appear, more flares erupt, more CMEs launch into space. We're currently in solar cycle 25, and here's what's making researchers nervous. When this cycle began, predictions said it would be mild, nothing extreme, a quiet cycle. Those predictions were wrong. Activity is rising faster than anyone expected. Sunspot counts already exceed early forecasts. Multiple X-class flares, the most powerful category, have already fired. And we haven't even reached the peak yet. The peak is expected between late 2024 and 2026. Right now, this year, next year. We are entering the maximum danger window. That's why 4 flares in one day matters. Not because disaster is guaranteed tomorrow, but because of what it signals. Somewhere on the sun's surface, A massive sunspot region is unstable. Magnetic energy is building faster than it can release smoothly, so it's releasing in bursts. 4 bursts in one day. That pattern tells scientists something important. The system is stressed, and stressed systems eventually break. Now here's the question you're probably asking. Can we see it coming? The answer is yes, partially. Solar observatories watch the sun constantly. SOHO, SDO, stereo. These spacecraft track sunspots, monitor magnetic fields, detect CMEs as they launch. When a CME heads toward Earth, warnings go out. Power grid operators reduce loads. Satellites switch to safe mode. Airlines reroute polar flights. But remember that number, 18 hours. Some fast CMEs give you even less, 15 hours. That's not much time to prepare a civilization that runs on electricity. And forecasting isn't perfect. Small changes beneath the sun's surface can trigger massive eruptions with almost no warning. We can watch, but we can't always predict. There's one more thing most people don't consider. Future astronauts traveling to the Moon or Mars won't have Earth's magnetic field protecting them. During a major solar event, radiation levels in deep space spike dangerously. A crew caught in transit during a powerful flare faces serious exposure risk. This isn't just about protecting satellites and power grids. It's about protecting human lives beyond this planet. So let's bring this back to last week. 4 significant flares, one day. What does that actually mean for you? It means the sun is active. It means we're climbing toward peak activity. It means the probability of a direct hit is rising. Not certainty, probability. Most eruptions will miss us completely. The sun fires in every direction. Earth is a tiny target. Most CMEs sail harmlessly into empty space. But probability adds up. Roll the dice enough times, eventually you hit the number. And unlike 2012, we might actually be in the path next time. We're not helpless. We have monitoring systems. We have warning networks. We have procedures in place. But 18 hours isn't much cushion. And some damage, once done, takes years to repair. High-voltage transformers don't come off assembly lines quickly. They're custom-built. They take months to manufacture. If hundreds fail simultaneously, replacement isn't simple. The 1859 event was a curiosity. The 2012 event was a warning. The next one could be the test. You're living through solar cycle 25 right now. You're watching a star enter its most volatile phase. And 4 explosions in one day just reminded us what that star is capable of. The sun isn't angry at us. It doesn't know we exist. It's just doing what stars do, building magnetic tension, releasing it violently, repeating the cycle. The question was never whether it would happen again. It will. The question is whether you'll be paying attention when it does. Because one day, the geometry will line up. The timing will be wrong. And what happened in 1859 will happen again. The only difference is what we choose to do with the warning. Right now, somewhere on the sun's surface, magnetic field lines are twisting, building, waiting. 4 flares was just a reminder. The sun is waking up.